तो कैसे हो आप लोग? क्यों देख रहे हो? तो अच्छे ही होंगे. This is Abhinandan over here, your coding buddy from iFutureTech for designing your future. Welcome you back to yet another comprehensive Python tutorial. Okay. If you have not yet subscribed to my channel, please do subscribe. Hit that bell icon to get notified. And if you have not yet watched my previous videos, I'll post that link into a I button. Please do visit and watch our previous videos as well. We have seen in our previous classes about the list, tuples, dictionaries, sets, numbers, strings, many different data types in Python. Today we are going to see about data type conversion. Let's dive into the example first and then we'll come back to see what exactly this is. So I have already stored one string over here in A. Also, I have stored B, that is integer. Also, C, that is nothing but another string. So let's see how we can convert one data type to another data type. That is nothing but if I want to convert this A, which is storing a string, my company name, to a list. So I can just do a list in a bracket, whatever the variable is, that variable name I have stored it. So I'll get the output as in the form of list. I can change it to tuples, dictionaries and set as well. So if I want to change an integer value, that is nothing but B, I want to change it to a float, I can just typecast it or change a type using float and a bracket, that's normal parenthesis, the variable name. So you will be seeing that the value has been changed to a floating point. Also, you can just change a string which is stored into C to integer by using a typecasting, that is the name of the data type int, and change it. So then we can change it integer to hexadecimal, integer to octal, or anything like that. So you can have anything to anything. Any data type can be converted to any data type using a data type conversion. So sometimes it is required to change or to perform a conversion between the built-in data types. To convert between the built-in data types, we need to simply type the name of that data type as a function and pass the value or the variable. It will automatically do a typecasting or change the data type of that particular variable. So let's see it over here by what all types we can change a data types. You have int, long, float, complex, you have strings, many different things are available, list, tuples, sets, dictionaries, frozen sets are available, character, unique character, yammer, un, even we have single characters, hexadecimal, octals. So these are the multiple examples where I can do a conversion between a multiple data types to any data types which is required. So one example, I have written it over here. You can have a clear look at this one and you try it with a different data types to convert one from another. Okay, so let's dive into another important topic of Python, and that is nothing but Python operators. So let's start with the basic operators. That is nothing but the basic operators are addition, subtraction, multiplication, division. Then we have modulus, exponent and float. So always remember the simple basic operations, addition, subtraction, multiplication, division are the simple operations. We have it over here. You can even have a look at the examples what I have referred it over here. So just go through it so that you will understand or have a clear idea about this, where I'm just considering the value of A and B as A as 10 and B as 20. Okay, so next is your modulus. So modulus is always going to give you the remainder that will be helpful in many different operations while we are performing any calculations or something like that. Exponent will give you the raise to, that is nothing but power, and also the floor is very important operator in Python which will give you or round off the value to downside. That is, you can see it in an example where I have written it over here. If I do 9 divided by 2, we are going to get a value as 4.5. So if I want a whole value, if I want a complete value to the next, that is nothing but rounding off to the next, then we will get it 5. If I want to get it 5 or 4 from 4.5, then I have to use seal, which is not available over here. So let's go with the floor. Floor is going to give you a round off value to below. That is nothing but if I have the answer as 4.5, it is floor will give me value as 4. The same with a floating point and same with the negative value. So if I just do minus 11 by 3, the answer will be minus 3.66, which will be, if I do a floor, I'm going to get the value as minus 4 over here. Okay, so I hope you are clear with the basic operators. Then let's move and see the next operators. Those are nothing but your comparison operator. Also, these are called as relationship operator, which are going to tell me the relationship between the left hand side to the right hand side, or we are going to compare the values of left hand side with the right hand side. Okay, so what it is exactly, let's consider an example where I am having a value 10 stored into A and 20 stored into B. So let's see how it goes around with the comparison operator, or what are the different comparison operators are available in Python. So we have equal to, not equal to, or greater than, less than, greater than or equal to, or less than or equal to. Now, whenever you are using a comparison operator, it is just going to give you answer in true or false. So remember that whenever I am using a comparison operator, I am not going to get any particular value, but only two values I am going to get. Those are nothing but true or false. And most of the times, these comparison operators will be used into looping or into the conditional statements that we will see it in our next coming classes over here. So I hope you are clear with a comparison operator or a relationship operator. The next operator, okay, you have the example over here where I have considered the example a value of A as 21 and the value of B as 10, and then we have done a comparisons using a if statement. So if and else, so you can just go through this and I hope you will understand it very easily. Okay, so let's move ahead and see the assignment operator. And any other programming languages we have seen, there is an assignment operator with a, for a simple example, A equal to 10. So what it does is, it is going to store a value 10 into A. So that means value 10 will be assigned to A over there, and that is called as an assignment operator. But there are different assignment operators are available in your Python, and those are nothing but add and assign, subtract and assign, multiply and assign, divide and assign, modulus and assign, exponent and assign, floor and assign. And also a normal assignment operator is also available in Python. Okay, so what it is going to do is, let's consider one simple example where the value of A is 10. I want to add 15 to A. So what I can do is, I can write it as A plus equal to 15. So the value of A was 10 already, and now if I do it something like this, so in short the meaning of this is A equal to A plus 15. Okay, so you can use this, so answer you will get it, and back it will be stored into A itself. So you can use this part, or else it will be useful when I am doing an increment operator, because increment operator is not available in Python. So you can use this trick to increment it by 1. It is something like A plus equal to 1. So it is going to increment the value of A by 1. Okay, so here A plus plus or plus A or A minus minus is not available. So for incrementation or decrementation, we can use these kind of assignment operators. So I hope you are clear with the these kind of operators also. Let's move ahead and see the example over here where I have considered the value of A as 21, value of B as 10, and value of C as 0, and perform the operations, different operations we have performed over here. Just go through the example, try this out so that you will have a clear picture about what and how these operators will be used depending upon the different situations. Let's move ahead and see the bitwise operators. So bitwise operators are going to add the bits. So here I have considered A is equals to 60 and B is equals to 13 as a values, and also I have represented the binary values of 60 and 13 over there. So if I want to do the bitwise operations, there are multiple bitwise operations are available over here. That is nothing but first one is AND, next one is or we have XOR, or we have the negation. Okay, operators are available, bitwise operators. So whichever the operator you are going to use it over here, that is going to do operations on bits. So this is an example where you can just use this trick to convert the decimal values to binary values. So you can use 2 raised to. So this is 2 raised to 0, 2 raised to 1, 2 raised to 2, and so on. So up to 2 raised to 7, that is nothing but 8 bits are available over here. You can use this trick and convert any decimal values to binary values. How it is converted is, you can see it over here, the value of value I wanted to convert is 60. So I cannot consider 28, so I have made it 0. I cannot consider 64, so I have made it 0. I can consider 32, so I have made it 1. So 32 plus 16 plus 8 plus 4, that is going to give you the value as 60. So only the bit 32, 16, 8 and 4 are made 1, and rest of all made 0. So it is going to give you the 8-bit binary value of 60. So you can use this trick to convert any binary, any decimal values to a binary value. So let's move ahead. AND operation, if you do AND operation, we know the truth table of AND. I hope you know, where the false is going to give you false, true is going to give you true, and any other combinations like true and false will give you false, false and true will give you false. Similar to that, you can have a look at the screen over here, and you can see that if I do 60 and 13, I am going to get a value as 12, because if I do a conversion 0 and 0, false and false, false, false and false, false, 1 and that is nothing but true and false, false, true and false, false. Only true and true are going to give you the value true. So if you just convert this binary to a decimal, I am going to get the value 12. So let me just demonstrate using an example over here, where if I just take a value A as 16 and B, we have considered it as 13. So if I just do this, if I do A and B, then I am going to get value 12. So how this we have got this value, that also we have discussed already. So if you do A or B, here only the false and or false is going to give you false. Rest all the combinations you are going to get the true value. So if you perform the operation for or, I am going to get the value as 61. So if I just do it A or B, then I'm going to get the value as 61. How it is done, you can see it onto the screen. Similar with negation. Negation is nothing but you are just going to just reverse the bit. If it is true, you are going to make it false. If it is false, you are going to make it true. Or if you see the XOR operations, where on a similar bit, I am going to get the answer as 0. On a different bit, different input, I am going to get answer as 1. That is nothing but false, false is false, true, true is also false, true, false is true, false, true is true. So if you use this trick and convert this, you will get the value over here for XOR as well as for negation. Even the bitwise operations are available, that is nothing but left shift and right shift. So left shift and right shift are available. You can just see it, have a look at this table, so you can have a clear idea about this. So if I consider a value 60 for A, and if I do a right shift means I am going to shift a bit two positions. That is nothing but here I have demonstrated about the left shift. So entirely this will be shifted to the left hand side. So two bits, these are going out, these are going out, then we have this one. So actually this is wrong. I have done a right shift over here. So A to right hand side. So 0 0 1 1 1 1. I'm going to get it. So if I do it right shift by 3, then I'm going to get this answer over here. So if I do it right shift by 2, all these two bits will be thrown out, then this we are going to get, and whatever the remaining bits are there, those will be padded with zeros. So remember that padding is very important. If you are leaving left with any of the less bits, then we are going to pad it with zeros. Same thing happens with the right shift also, and same thing happens with left shift also. So if you do right shift, then it should be shifted. Which should be shifted to the right hand side. The number which you have mentioned. Here we have mentioned 2. So right shift by 2 or left shift by 2. This is left shift, but answer is wrong. Okay, do not consider this. So if I just show you over here, so A right shift by 2, then I am going to get the answer 15 because I am shifting it to the right hand side. And if I do the same reverse operation by 2, that to the left hand side, then I am going to get the answer as 240. As I have mentioned it here into the table, you can just verify this. So I am going to get this answer, or I am going to get this answer for right shift. I am going to get it 15. For left shift, I am going to get it 240. Okay, so I hope you are clear with the bitwise operations as well. So let's move ahead and see the example over here where I have considered the value of A as 16 and value of B as 13 and value of C as 0 and perform the operations. I have stored an AND into C, OR into C, XOR into C, and just explained examples, the bits also in front of the examples in a comment section. So you can just have a look at the program, try out with this program, and I hope you will get the similar output what I have got the output over here. Just go and try this out so that you will be clear with the bitwise operations as well. Okay, so this is all guys. Thank you for watching my videos. If you have not subscribed to my channel, please do subscribe it. Please tell your friends to watch the videos which I have pinned it into the I button. So I hope you are having a good time. So adios amigos, let's see you in the next video.